Every nuclear power plant screens hundreds of condition reports every month. Most plants still do it the same way they did it 20 years ago, manually. CapAI is a machine learning model trained on your plant's own historical condition report data, not a generic AI. It learns from the classification decisions your screeners have already been making. When a new CR comes in, it reads the full narrative, predicts every screening field, and returns a confidence score alongside each prediction. Autoflow then applies your rules, routing high-confidence predictions automatically and flagging everything else for a human reviewer. Every prediction comes with a confidence score, a number between 0 and 1. You set a threshold for each field, and predictions above that line are processed automatically. Below it, a human reviews it. For reportability, something with real regulatory consequences, you typically want a very high bar. For something like department routing, you can afford to run lower. The risk of a wrong call is different. Keep in mind the system doesn't choose that balance for you. You do. Automating decisions in a nuclear environment requires more than accuracy, it requires proof. Even when the system is highly confident, a random percentage of auto-processed CRs still go to a human reviewer. This continuous quality sampling is built into the design. Every decision is logged. Every prediction, every confidence score, every routing call. If a regulator asks why a specific CR was classified as non-reportable 6 months ago, you pull the record. Everything is there. No plant is automated before it's ready. We start by training a model on your historical data, then reviewing test results with your team before anything goes live. Then comes what we call recommendation mode. Every CR still gets screened by a human, but CapAI's predictions are pre-populated alongside. Your team sees what the system sees before they ever trust it with an automated decision. Only then does automation begin, at conservative thresholds with high sampling, monitored closely. The pace is set by measured performance, not a calendar. In mature deployments, plants typically screen 50 to 80% of CRs automatically. There's a full audit trail on every decision and continuous human oversight on a 5 to 10% sample. Let's look at how that's actually configured inside the platform. This is the Autoflow screen, the configuration layer that sits between CapAI's predictions and your live Cap workflow. Before this screen exists, Nuclear maps your plant's full screening process, every decision point, every downstream step, every role. Autoflow is then built to mirror that process. What you're looking at here is where those decisions are configured. Each row here is a classification field, a decision that CapAI makes for every incoming condition report. This column is the confidence threshold. It's the line you've drawn for that field. Above it, CapAI handles it automatically. Below it, the condition report goes to a human reviewer. Notice that different fields have different thresholds. Reportability sits high, 92 to 95% or above, because the regulatory consequence of a wrong call is real. Something like an assignment group can run lower. If the routing is roughly right, that's usually good enough. And here's an important design decision. Autoflow treats each CR as all or nothing. If even one field falls below its threshold, the entire condition report goes to manual review. There's no partial automation. You can also disable automation for specific label outcomes entirely. If your organization always wants to manually review any CR flagged at a high significance level, regardless of confidence, you configure that here. This field is one of the most important in the whole configuration, and it's easy to overlook. Even when CapAI is highly confident in a prediction, this percentage of those auto-processed CRs still gets randomly pulled for human review. Without this, once automation is running, you have no ongoing way to know if the system is still performing well. Data changes, models can drift. This sampling mechanism is your continuous check on system accuracy. New deployments typically start at 100%. Every auto-predicted CR still goes through a human screener. Over time, as confidence builds, that rate comes down to 5 or 10%. You can go lower, but you're always keeping a human in the loop. If you need to make a change, say adjust a threshold or modify a sample rate, you create a new configuration, make your changes and promote it. The previous version gets archived, not deleted. This means at any point in time, for any condition report that's ever run through Autoflow, you can pull the exact configuration that was in effect. That's not just a nice to have. In a regulated environment, that's how you defend a decision. This is the audit log. Every condition report that's ever been submitted to Autoflow has a record here. For any individual record, you can see exactly what data was provided to the model at the time of prediction. Not what's in the source system now, but what was there at that exact moment. You can see each field's prediction, the confidence score it came back with, whether it met the threshold, and the routing decision that followed. You can also see if it was included in the manual sample, and if so, what a human screener actually classified it as. That comparison is how the system knows whether its predictions are holding up. This record is your answer to any audit question. Pull it by CR number, pull it by date range, or even pull it by field. Everything is there. Here's a feature that's particularly useful when a prediction looks wrong. If you're reviewing an audit record and you disagree with how a CR was classified, you can pull up similar condition reports from your plant's historical data, the same training data the model learned from. Often what you'll find is that the model isn't predicting in a way you wouldn't expect. It's predicting consistently with how your plant has classified that type of issue in the past. This dashboard is how you know the system is working, and how you catch it when it starts to drift. Things like automation rate over time, accuracy rate, and confusion matrix, which is what the model predicted versus what actually happened after human review, can all be tracked here. If the system is degrading, whether from a change in how CRs are being written, a shift in your data, or just model aging, the trend lines here will show it before it becomes a problem. For a compliance team, this is also your ongoing evidence that the system is performing as configured. A lot of automation platforms were built for other industries and adapted for nuclear. CapAI was built for nuclear CAP programs from the start. The models are trained on nuclear language, nuclear classification standards, nuclear workflows. Everything you just saw in the platform, every threshold, every audit record, and even every human review is a part of the design philosophy.